let's now proceed with systems of linear equations with complex coefficients. So for a given system, A11W plus A12Z is equal to K1, A21W plus A22Z is equal to K2. So this can be expressed in augmented matrix as the coefficients of W, the coefficients of Z. So A11, A21, that coefficients of W, coefficients of Z, A12, A22, WZ is equal to K1, K2. So how do we solve for the unknown values W and Z? So we are to use Cramer's rule. So how is this Cramer's rule? So Cramer's rule basically is gagamit lang tayo ng determinants. So, paano ba kinukuha ang isang determinant? Say, for example, I have a given matrix A, B, C, D. So, if I'm going to get the determinant of that A, B, C, D, all I need to do is to take the product of this down diagonal. So, that is AD minus product nung up diagonal. So, that's BC. So, that is the determinant of that particular matrix. So, all I need to do is to take the product of the down minus product of the up. So what is this W? So that's the determinant of dW over the determinant D. So for Z naman, it's dZ over the determinant D. So what is T? Determinant of, so from our augmented matrix A11, A21, A12, A22, so taking the determinant D, and then for dW, the column W must be replaced with a constant column. So instead of A11, A21, dW is K1, K2. So, replacing that constant column dun sa W column, A12, A22. So, kung ano yung subscript dito, yun yung papalitan. So, for DZ, so that's A11, A12. So, since DZ to, papalitan natin yung column Z with constant term K1, K2. So, then take its determinant. So, this is down minus up, down minus up, down minus up, and then substitute it here to solve for the value of W and Z. So let us try to apply this Cramer's rule to solving this particular system of linear equations. So let us try solving. So in that case, iaano muna natin siya into its augmented value. So this is 5 plus 4i, 3 minus 4i para sa W. And then this is negative, so I can change the sign of the subtrahend. Ito yun. So, ibig sabihin, magdidistribute lang tayo ng negative, so that this becomes positive. So, that gives you negative 6 plus 2i. And then this one is negative 1 minus 3i. So, that's your determinant. WZ equals 2 plus I, 8 plus 5i. So let us try to get the value of W. What's W? dW over the determinant of T. So let's get the determinant first. What is the determinant D? So the determinant D is the determinant of this matrix. So this is 5 plus 4i, 3 minus 4i, negative 6 plus 2i, negative 1 minus 3i. So all I need to do is to take the product of this down. So that's 5 plus 4i multiplied by negative 1 minus 3i. So product of that minus product of that up diagonal. So that's minus 3 minus 4i multiplied by negative 6 plus 2i. So multiplying, that gives you negative 5. Negative 5 times, 5 times negative 1 is negative 5, minus 4i, minus 15i, minus 12i squared. So that's 5 times negative 1, negative 5. 4i times negative 1 is negative 4i. 5 times negative 3i is negative 15i. And then positive 4i times negative 3i is negative 12i squared. So minus the quantity, multiplying, that's negative 18. This one is plus 24i. This one is plus 6i minus 8i squared. So simplifying this, that gives you negative 5 minus 19i This is negative 4 minus 15 is negative 19i. This becomes plus 12 because I squared is negative 1 times negative 12 is positive 12. Similarly, like I squared is negative 1, so that becomes positive 8. So minus the quantity, negative 18 plus 8 is negative 10 plus 30i. So that gives you 7. Negative 5 plus 12 is 7 minus 19i plus 10 minus 30i. So this gives you 17 minus 49i. So this will be our determinant D. So that will be the denominator, 17 minus 49i. 17 minus 49i. So let's solve for dW. What is dW? So our dW is replacing W column with the constant column. So that gives you 2 plus I, 8 plus 5i. Then copy lang yung Z column natin. So that is negative 6 plus 2i, negative 1 minus 3i. So then evaluate this determinant. That's down minus up. That's 2 plus I multiplied by negative 1 minus 3i minus 8 plus 5i multiplied by negative 6 plus 2i. So simplifying, that's negative 1 minus I. Sorry, it's negative 2. 2 times negative 1 is negative 2. I times negative 1 is negative I. Then 2 times negative 3i is negative 6i. Then that's negative 3i squared. Because I times negative 3 is negative 3i squared. Minus the quantity, negative 48 minus 30i plus 16i plus 10i squared. So that's negative 2 minus 7i because this negative I and negative 6i is negative 7i plus 3. Again, I squared is negative 1 times negative 3 is positive 3. Same with 10 times negative 1 because I squared is negative 1. Minus the quantity, negative 58. So this is negative 48 minus 10 is negative 58 minus 16i. Sorry, it's 14. Negative 30 plus 16 is negative 14i. So this is 1 minus 7i plus 58 plus 14i. So you just have to distribute this negative here. So that's why it's 58 plus 14i. And that's 59 plus 7i. So that will be our dW. Then dW therefore is substituting this 59 over plus 7i. So that will be our numerator. 59 plus 7i. So how do you solve for this? I just need to multiply this 17 plus 49i, 17 plus 49i. So I think I'll be needing a calculator here. So multiplying, that gives you 59 multiplied by 17. So that's 59 times 17. That gives you 76. No, it should be times. That's 1003. 59 times 17 is 1003. Then 17 times 7. That gives you 119i. This 49i and 59. So that's 49 times 59. That's 2,891. 2891 I, and then 49 multiplied by 7 gives 343i squared plus 343i squared all over a minus b. A minus b times a plus b is a squared minus b squared. So that's 17 squared minus 49i raised to the second power. So which gives this 343i squared becomes negative 343. You need to subtract 343 from 1003. So that's 1003 minus 343 gives 660. So that's 660. Then this 119 plus 2891 gives you 3010. That's 3010i. That's 3010i all over 17 squared plus 49 squared. So this gives you 14 squared minus 49 squared I squared. But I squared is negative 1, preceded by a negative becomes positive. So this should be, this is 17. So therefore, this is 17 squared becomes positive because it is preceded by a negative. So 17 squared plus 49 squared is equal to 2690. So that gives you 2690. So therefore, our W is equal to, your denominator is 2690. So this is 660 plus 3010 I over 2690 gives 66 over 269 plus 301 over 269 I. So the value of W is dividing 660 over 2690 plus 3010 I over 2690 gives you 66 over 269 plus 301 over 269 I. So that will be the value of our W. So let us try to store this kay A para for checking purposes later. So all I need to do is to press Shift RCL to A. So therefore, I have stored this answer for letter A later for checking purposes. So now, we are done with W. So we can now solve for DZ. So Z is DZ over the denominator D. So let's solve first for DZ. So what is DZ? So let's go back to our matrix. Replacing this Z column with the constant column 2i, 2 plus I, and 8 plus 5i. So this is 5 plus 4i, 3 minus 4i, and then you have 2 plus I, 8 plus 5i. So taking the determinant, so again, this down minus up. So this is 5 plus 4i multiplied by 8 plus 5i minus 3 minus 4i times 2 plus I. So this gives you 40. 5 times 8 is 40. Then this is 32 plus 25. So that's 32i plus 25i plus 20i squared. So that's 4 and 5i and I is 20i squared minus the quantity 6 minus 8i plus 3i minus 4i squared. But then again, I squared is negative 1, I squared is negative 1. So which gives you 20. 20i squared is 20 times negative 1 is negative 20 added to 40 is 20 plus this is 57i. That's 32 plus 25i minus the quantity 6 minus minus 4 is 10. So that's negative 4 and negative 1 is positive 4 plus 6 is 10 minus 5i. So this DZ therefore is 10. You need to distribute that negative. So that's 20 minus 10 is 10. Then this negative to negative becomes 57 plus 5 is 62i. So that is 10 plus 62i. So that's the value of our DZ. So substituting it here, that's 10 plus 62i over the determinant D. Our determinant D here is 17 minus 49i. 17 minus 49i. So, but then again, I need to multiply this by 17 plus 49i by its conjugate, 17 plus 49i. Which gives, again, let me use my calculator. This is 17 times 10 is 170. This 17 times 62i, so that's 62 times 17 gives 1054i. This 10 and 49 is 490i. This 62 and 49, so that's 62 times 49 is equal to 3038. So that's 3038i squared. And then this one is 17 squared minus 49i raised to the second power. So again, this 49i squared is 17 squared minus 49 squared I squared. So but this I squared is negative 1 preceded by a negative becomes 17 squared plus 49 squared. So that will be our denominator. So our z now here is equal to, so this is our z, simplifying. So this is 170 plus 3038, but this is negative. So this gives you 170 minus 3038. 170 minus 3038. So that will be negative 2868. So that's negative 2868. And then for our imaginary part, so that's 1054 plus 490. That gives you 1544i. So that's 1544i. 1544i all over, this gives you 17 squared again plus 49 squared is 2690. 2690. So that's 2690. So simplifying, z is equal to negative 2868 plus 1544i divided by 2690. So the answer there is negative 1434 over 1345 plus 772 over 1345i. So that will be our answer. So that's for letter Z. So let us try to check our answer. So let me store this to B. So this has been stored to B on my calculator. So to check our answer, let me just substitute to our given. So I have used A for W and B for Z. So if I'm going to substitute 5 plus 4i times A minus 6 minus 2i times B, the answer should be 2 plus I. So let us try. So 5 plus 4i, we have stored our W here to A. So let me recall that. That's alpha A minus 6 minus 2i. Let's recall what we have substituted. Our Z is stored in B. So let's recall B, alpha B. So that gives you 2 plus I. So that is 2 plus I. So therefore, our answer is correct. So to double check, substitute naman natin dito. 3 minus 4i alpha A plus negative 1 minus 3i alpha B. So that's our stored value for letter B. So that must be equal to 8 plus 5i. So therefore, our answer is correct.